Question 5 deals with your exponent properties and rules. I put all 4 properties up there, the product, quotient, power, and negative exponent. These are the 4 properties that you need to know about exponents, but we're going to simplify this expression that they give us in problem number 5. So when we simplify, we know we've got this 56 divided by negative 14. And 56 divided by negative 14, I believe 14 goes in there evenly 4 times. So that's going to give us, if we take 14 times 4, just verifying, yeah, that gives us a 56. So this is going to give us a negative 4. And I'm going to put it over a 1 because I'm reducing. Negative 14 goes into negative 14, or 14 goes into 14 1 time, and it goes into 56 4 times, so we have a negative 4. Now I'm going to look at the c's, and the c's are c to the 5th over c to the 7th. Well, if I look at these properties that I have here, the quotient property says when you divide like bases, you subtract the exponents. Now the phrase like bases are, their bases are both c, so all I want to do is I want to subtract their exponents, and I've got c to the 5th over c to the 7th. So it's c to the 5th minus c to the 7th, which equals c to the negative 2. But a negative exponent says you can write it as 1 over c squared. So now apply the negative exponent rule. That's really what's going on behind the scenes. Typically when we do these, we start looking at this expression. We say, where do you have more c's, on the top or the bottom? And we can quickly recognize that we got 2 more c's on the bottom than we do on the top. So we're going to get rid of all 5 of these. We're going to be left with c squared. So reducing in that manner probably is a little bit easier. Then we're going to look at our d's, and this time we have, I'll just come over to the side here, d squared over d, and that's equal to, if I got more d's on the top and the bottom, I can reduce one factor d with a factor d on the top, and it's d over 1. So these d's become d over a 1, and then the e's, applying the same strategy as e over e cubed. If I've got more e's on the bottom than the top, I actually have 2 more e's on the bottom than the top. So I can reduce one of the e's on the top with one of them on the bottom, and we get e squared. So now multiplying straight across, we got a negative 4d times 1, which is still negative 4d, and 1 times c squared times 1 times e squared is c squared times e squared. So we're looking at a simplified version of a negative 4d all over c squared over e squared. So I went into a little detail about these negative exponents to plug this property a little bit, but in essence, when we do these, we can start spying on those exponents and say, where do we have more e's, where do we have more d's, where do we have more c's, top or bottom, and then just see how many more are on the top and bottom. By using the phrase how many more, we're implying we're going to subtract to figure out how many more there actually are on the top or the bottom.